actually, while I'm on vacation, I needed a project to do, and so kind of like what something to take photos with, and my first thought was something that flies, but I quickly realized I needed a control board of some sort. Couldn't really get that locally easily, or in time because I had it about a week before I left, and so it turned into underwater because it's relatively simple. The controls are kind of forgiving. You can just kind of burst and stuff. You're moving through water, and there's a lot more resistance, and you stop, it'll mostly stay where it's at.
Doesn't crash.
It doesn't, yeah.
Crash.
So that kind of turned into, okay, what do I need to get this to do? I need to learn enough to be able to find out what I need to order, so I can order it very soon so that they can all arrive in time, or find it in local stores, which some of the stuff I was able to do, some not. Needs to be portable because it's a 10-hour drive to where I need to be on the trip, and need to be able to take that car along with all the rest of the gear. And then no computer. I couldn't leave my computer in the loop, or I wasn't willing to, because I'd be sitting next to a lake, possibly on the lake, didn't want water in the system. Needs to be all kind of, could be damaged, and I wouldn't care too much parts. So timing, I started this on a Wednesday, was leaving early the next Wednesday morning. So of course right in the middle of the weekend, that makes ordering stuff interesting, so that what can I find locally again? And a lot of the hobby shops online are not known for their quick shipping. One that I ordered from the US warehouse, which is limited stuff. Their primary warehouse is in Hong Kong, and use the base to get stuff, and that was just not an option. And doing a quick inventory of local hobby shops of this kind of stuff, most of what they sell is larger parts, or like frame type stuff, not a lot of the internal components. At least that finding online without actually visiting everyone. So, and then I was working every day before I left, so I couldn't hit just the weekends. So for the main body, I thought PVC, I can get that locally. Lots of options, not a big deal. Power, steel lead acid batteries, should just with the displacement, because it doesn't fit in there. Hopefully keep it, so it will be movable underwater, relatively neutrally buoyant. I'll probably have to order motors and speed controllers for those motors. Props, maybe I can get them locally, maybe not. Kind of got a mix of that in. Because it's underwater, I really no way to use radio on this. Had to tether it, which Cat 5 would be a great option if it works, because it's lots of conductors, relatively light, and don't have to worry about power. Controller, I figured Arduino for whatever translation I need if I couldn't do it directly. Couldn't do with this. Controls, I figured I'd just use switches. Ended up realizing later to use a full analog joystick. And then for navigation, because I didn't expect to be able to see it might be on 2 feet underwater, put a camera on it. I wanted to record it, but I figured I could use the GoPro for that, and that would work well, be high quality for the recording, but I didn't want to kind of try to build my own waterproof casing for that, because it's a relatively expensive camera compared to the rest of the project. So I just bought a cheap NTSC camera and just an analog video as kind of compromise, just that whole kind of thought through tools. Didn't think everything I have around the house should be able to do this. I didn't foresee anything special I need to plan for. So decided to order the motors and speed controllers first, then do the body. Maybe over the weekend, browsing stores and stuff. Order the camera sometime in there, then lay it all out, start cutting it up, and then the controls kind of last. Didn't quite end up going that way, but here's the schedule that ended up being. Idea Wednesday, ordering and visiting stuff most of the weekend days, and then the next Wednesday, the third there, leave for the trip. And then 2 days later, I ended up actually getting in the water. It didn't, that one Wednesday was an all travel day, so I didn't end up doing much work then, but yeah. So how am I going to make this thing move? Basically, going to be looking up front, so I want cat 3 degrees, 2 translation up and down, and forward and back, and then just yaw rotation to pitch, kind of same thing. I don't need to be able to actually look up or down as much. I can go up or down if I need to. Um, and for rather than trying to do sort of like control surfaces and having to figure out how to house moving parts underwater, I just decided to use just the thrusters for everything. One of there's, I guess, as part of this, brushless motors, the way they work, they're three-phase motors. There's no brushes or commutation of any sort. It's, you know, wires up to windings, and then the magnets are on the rotor, and so there's no, they work underwater without any real issue. I mean, there's possible a little loss across, you know, stuff that with the 12 volts and, fresh water, it's not really an issue. So they're quite powerful relatively, and give me a lot of options. There's lots of motor options because these are that's basically used for all sort of RC stuff at this point. And I didn't want to go too fast because one, it requires a lot of power, and I was a little worried about what the seal lead acid would deliver. Like the motors I ended up picking, for example, can draw up to 18 amps, and the two 3.6 amp hour batteries, even in parallel, I was worried about one of the motors, let alone three. So I went for smaller props and ended up undersizing a little bit for the first drop there. But and then also I didn't want to spin the motor too fast, end up just cavitating, wasting most of the power. So try to relatively lower speed and get larger props, kind of to this trade-off there too. So speed controllers. They make speed controllers for boats, for brushless motors, but they don't have reverse because boats, or most of them don't. Airplane ones, again, you don't run your airplane prop in reverse. Ended up finding car PSCs, and that was kind of my best option. They are also handle a decent amount of power. Most car motors, model car motors, are quite a bit more power than airplanes, actually. Props, I preferred counter rotation because I was getting a thruster on each side. Ended up not finding what I wanted locally for that, so didn't get that, and it'll be obvious in the video later actually. It does torque the body of the thing quite a bit. Didn't want to go too large. Actually, my initial order, when I ordered the motors, I ordered some counter-rotating props along with it. They were 5-inch ones that are actually these, and I ended up not using those in favor of some smaller ones, which I might or may not have with me, that fit into 2-inch PVC that size. And those were actually, because these larger ones are not necessarily designed for water, they're designed for air, and the other props I got at the local hobby shop were for water. And I thought, well, the pitch is a little better for that, but yeah. So I ended up making that order on Friday for the motors, DSCs, and then picked up the boat props on the Saturday. For the tether, thinking through what I needed, I didn't need to do power, so I didn't need heavyweight cables, just control cables. Video, give it its isolated pair, hopefully prevent some interference. So that's 2 wires. Then I have 3 servo pulse RCs, basically work on servo pulses that are 1.5 milliseconds is neutral, and then can go down to 1 or up to 2 for each full deviation. And the speed controllers work the same way. It's all designed to be run by the same RC links. So basically, I need 3 signal wires, and I just share the ground because there's no power actually going over those. But your Cat 5 has enough for discrete control. I'll do that. And I don't need to do any sort of special protocol. I just send the raw signals down, and all the smarts can be up on the shore side then. And then I had extra wires, and if those controls were lightweight enough for power, I could actually run power back up and not have to have a separate battery. I figured I need at least 50 feet. Shouldn't be an issue. I actually found 150 feet was a good price point for $10 for the cable, so I ordered that on Friday as well. So, for the body, I basically just went to Menards and said, I had a few requirements. What are their options? What was it?
Mini trips.
Yeah, mini trips. body parts on Sunday, but, for the basically round pipe for the main, for guts for everything. The batteries, looking at what I had, the 3.6 amp hour, 12 volt batteries fit, they're like 3.6 inches diagonally across, so I figured 4-inch pipe is, my option. And a lot of people have used PVC beams for the front lens because they have a nice O-ring on there that you can clamp down against to put like Lexan or probably carbon or whatever. And I figured I'd try that way, but the 4-inch PVC beams just aren't easily available for any sort of reasonable price. So I ended up building one out of junction and a little piece of pipe with it. I just took a female coupler here and cut this last 1.5 inches or so with a piece of the 4-inch pipe, slid it in there such that there would be a little lip here. And then I cut Lexan to fit just that size, put a bead of epoxy around there and pushed it in there, and then I silicone sealed it outside just to, all the cracks around it. And that has worked very well. The one drawback is I had it stuff so it would be set back a little bit here, but I didn't have enough kind of latching in place. So it ended up both the board inside and the camera lens pushed against her. There's nice rings around there as I screwed it on and off before. So, so that's this. I was looking at larger frame options, and for going around similar to what I have for that one, I decided against it just for complexity. I didn't really need it. Thought it won't sit flat on the ground, but I don't really care how it sits on the ground as long as it's stable. It's in the water that matters. Turns out it probably would have been better to do that, and it would have had a little more control, put the thrusters out as opposed to against the side of the body. For the thrusters, I ended up wanting to shroud them, so I just used 2-inch PVC that they could fit in. That was another reason for going down from the 5-inch on the initial setup. How I determined the size of that? Does it fit? 1.5 inches to the left, motors don't fit, not an option. 2-inch it fit, and it seemed like there was enough space around there to make up for the prop volume, so I decided to try that. And turns out that locking pipe was not the issue. The props had other issues in there, but that's later. Kind of mentioned this already, the camera, I'm concerned for leaks on it, so the GoPro was staying in its waterproof case. It was not coming out in my custom built stuff, especially because I didn't have any leak monitoring in the pipe when it was underwater. Just picked up a cheap, little camera, and then just wired it straight up to the top. Screen for just navigation, I thought a small one would work. I was thinking 4-inch initially, went up to a 7-inch. They were still relatively cheap, and I figured I could use that for other purposes, not a big deal. They're designed for cars, they fit backup cameras or entertainment systems, so they're all 12 volts, so nice run-off batteries. For that I ended up, I guess I had an extra cable in the tether. I could have just run 12 volts up. I put another battery on the surface. Maybe I was just worried about battery life at the time, I don't know for sure, but ended up ordering those cameras from Amazon. For the controls, I was thinking initially switches. I was just gonna find some surplus switches and just do on-off each direction. Then I realized that I could cannibalize a joystick. They should have some sort of variable, sensing in there. And so started looking a little bit. Turns out, old style joysticks, before everything moved to USB, it was actually all analog on the cable, and the computer interpreted it. So it's just 100K 10 channels, exposed. That's center and one end to what turned to 5 volts, and then the switches are linked to ground. A lot of joysticks will use that 5 in the ground for extras. The ones, a lot of button repeat stuff would do that. The one I had didn't, so it turned out not to matter. Figured I'd add a couple resistors to balance it off, and then my hardware set. I just input those into the controller. It does turn out soldering to the right reference is good, because I ended up having to reverse some stuff in software because I put the reference against +5 instead of negative, or instead of ground, and I was basically trying to do the window of +5 to midpoint on it, and ended up it's in the other one, and I had to reverse the ramp into all the calculations. Y, I did, basically ramp one up and down. Rather than leaving some gap so it can go past the normal full, I just capped it, which meant that if I was at full speed, I couldn't turn as fast because it could only drop one, it couldn't raise the other motor speed. So it actually will turn a little faster if it's idle, but I figured that was not a big a deal. I wanted to be able to do full motion on it. For the up and down, I kind of wanted to be able to have a little more than on and off, to be able to hover at a depth, basically. So rather than just on and off on the motors, I set it up so that you hold the button and it'll ramp up, and then when you release it, it'll slowly ramp back down. Basically, I can go either way. That if it hit the end, it would just stay there. If I want to drop to 0, I can just tap the other side and basically allow it reset. Especially because it didn't have other feedback other than watching the craft move. It was nice to be able to know that it hit center with that. So after I got this set up, I kind of had to move some sort of, this was doing before the break.
Wonderful picture.
So yes,
I love it.
completely messy stuff. I ended up having how do I test this? So I can hook it up to the speed controller. So it's really hard to see what input they're actually getting there. It's hard to eyeball this RPM of this motor, easily. So I just said I'll just hook it up to servos that I already had a 2 servo camera mount that I put together several years ago that I hadn't been using. I'll just plug that in. So here's basically testing the motion, its relative, X and Y, do their things, and then it can do, wow. So just control translation. Then I had quoting right there. So that was just, okay, that works, that's done, and put it off till the next, till it's needed to actually integrate at that point. So how to do the body. Front to back, I just have a Lexan window up front. Then I talked a little bit about this, about 1 inch of the 4-inch PVC, the female coupler, male coupler, the rest of that body, which was a mistake to do that much, and then a PVC end cap on the far end. Basically, those 2 couplers, that's the only openable section without breaking glue, and I put Teflon tape on there to seal it, and also to give me able to screw it on very far at all. I wanted to be able to open it easily, but I didn't want to push the wires, and that's why they only opened at the front as opposed to the back. So basically, I could pull the wires out and then slide it all in. Kind of, I guess I already discussed this side of it, what it did. But you'll see it better out here, or you can come up afterwards and take a look at it too. But it did end up looking the nicest at the end. There's a little rough edges, but it works and keeps water out. So how do I do the tails with the wires? Each of the motors, they're 3-phase. There's just 3 wires to each of them. So we need 9 wires out the back, single conductors, and then 1 Cat 5. And water can run down the inside of these wires if there's any sort of nick in it. Cat 5 is notorious for being easily nicked in that regard. So I needed to seal down to the bare wires. For the, I decided for strength to put a hole per outer cable jacket, as opposed to trying to put them all through 1 big hole or whatever, and also for a little strain relief, stuff like that. And then I just potted the whole thing at the back end in epoxy once it's done and sealed. So for the Cat 5, I had to basically split it all apart at that point anyways. The wires will not take stripping in the middle of the wire, just strength-wise. And since the ends are already pre-made, I said I'll just cut the wire, pull it all apart, solder each of them separately, and put them back together. Keeping them not touching was a little bit of a pain with any sort of flexing. And then I realized I'm going to have a little bit of 3D space here, so I actually staggered them vertically as well before I ended up potting them. See the zip tie up at the top? I actually used those along each of these wires to prevent, that's where it basically held it against the back, and that was kind of a strain relief until the epoxy got hold the whole wire at least. So this is it potted at the back for seals. You can see a little bit here, copper. For these wires, I basically took a wire stripper, cut it and just pulled it a little bit so it just initially we did cut and resolder them. That's a lot of work. You know, with the legs, I was, 2 feet on either end. This would work it up. Didn't work for the Cat 5 though, so. The 2 bolts are a charging scheme, so I could theoretically charge without opening them, without agreeing to Teflon tape and stuff each time, or at least fully inspect it. But yeah, so that, I pounded that and let it sit overnight. Lots of uses zip ties for, holding stuff together, just holding it in place, a little bit of tape. Again, I brought all these tools with me because all this assembly is happening on the trip. So I had electrical tape with me, so that ended up being it. Charging wasn't such a great idea, as you can see by the bolts. It wasn't enough to cause noticeable load on the system, but it was definitely enough to have some metal migration on those bolts. You can see the epoxy leaking through these a little bit here. Comes with straight indents. But I grouped them also for the 3 different motors, left, right, and top. And then the Cat 5 tether was basically centered. At this point, the whole thing was a little bit of a pain for manipulation because this is 14 gauge ground wire that I happen to have, which I was a little hesitant making all my power conducting wires be green, but I decided it's not enough power. Okay. But at this point, I had 150 feet of Cat 5 coil up on it, and those wires were stiff, and there's a couple feet because I wanted to be able to have them come up in front of the pipe, and then I didn't know where to position the thrusters at that point. So it kind of let's get it set and not have to touch it hopefully, because it was a bit of a pain to move around. Inside layout. I used a 1/4 inch hardboard here as a platform. I wanted to be able to hold stuff in place relatively fixed without having to be reaching down inside there. I just didn't have space also to reach inside there with my hand, and there wasn't a clear throw of batteries. So I put a battery on each end for balance, so I wouldn't have the front or the back being a ton heavier than others. Mounted the camera up front. I kind of did a power bus through the center, if you can call it that. It's basically wires with butt connectors, where how I did all the junctions was these are 10 to 12 gauge connectors. I'm mostly dealing with 14 or 16 gauge wires, so I just stuffed multiples in each end and encrypted 12 until it held. And then, so each of these had off of it a pair for the speed controllers. So there's 3 speed controllers powered off this, and then this bridge was for the charging connectors on the back. I should note the 12-volt system for the main power for the speed controllers was how everything else is powered. All the controller electronics are actually powered by a relatively standard feature of speed controllers is a battery elimination circuit, they call it, where you run your RC craft off with one, usually LiPo pack, and the ESC will drop that